Hi, welcome back to another video. Today we're going to look at an acid-base question. So question 19 reads, a hydrochloric acid solution, HCl, is standardized by titrating it against 25 cm cubed of a 0.04 moles per dm cubed sodium carbonate solution. At the end point, it is found that 19.5 cm cubed of HCl has reacted. The balanced equation is given below. Question 19.2.1, calculate the concentration of HCl. So I'm going to start off by writing out the information that I have, just so that it's easier to follow. So there's two things. There's the acid, which is HCl, and then there's the base, which is Na2CO3. Now, the information that I've been given about the base is that I know the volume is 25 cm cubed. I know that the concentration is equal to 0.04 moles per dm cubed. For the acid, I know that the volume is 19.5 and I don't know the concentration. Now, since this is a titration, I can use the titration formula that reaches endpoint. And so the formula is CAVA divided by CBVB is equal to NA over NB. Now Ca is concentration of acid, Cb will be concentration of base. Na, number of moles of acid, Nb, number of moles of base. But the benefit of using this equation is that we don't have to actually calculate the number of moles, we just need to use the mole ratio from the reaction. So Ca is what we want, so concentration, and then the volume of the acid. And another benefit of using this formula is that you don't need to convert the volume to dm cubed. So I can just simply put 19.5 and divide it by Cb is the concentration of the base, which is 0.04, and then multiplied by the volume of the base, which is 25. And that's equal to Na over Nb. Now the ratio from the reaction, HCl is 2 and Na2CO3 is 1. So the ratio is 2 to 1. Now we can calculate the concentration. And when we calculate the concentration, we get 0.1 moles per dm cubed. So actually, the answer that was given to us here, that's actually incorrect. Okay, let's move on to the next question. 19.2.2. Suppose a few drops of water were present in the burette before it was filled with the hydrochloric acid solution. How will the volume of HCl solution needed to reach the endpoint be affected? Greater than, smaller than, remain the same, and then give a reason. So what I'll do is I want to just quickly draw just a sketch, right? Say this is my acid and I have maybe, let's draw 3 molecules, right? So 1, 2, 3 molecules. And those 3 molecules are in a solution and it was 19.5 cm cubed. Now, if in the burette there's water, then what's going to happen is the water is going to actually increase the volume. So the volume is going to increase to whatever value, maybe let's just say 25, right? But the number of moles or number of molecules is going to stay the same. So it's the only thing that it's going to do is so adding the water is going to dilute the acid. So I have the same amount of moles, but in a larger volume. And it's going to increase the volume. So the question is asking about how will the volume of HCl solution be needed. So you're going to need more of it because the volume has increased. Okay, so to get this, in other words, to neutralize the same amount, you're going to need a larger volume. Okay, let's move on. A concentrated household product, ChemClean, contains ammonia as the main cleaning agent. To determine the amount of ammonia present in 1 dm cubed of ChemClean, the following procedure is followed. 20 cm cubed of ChemClean is added to a 250 cm cubed flask. The flask is then filled to the 250 cm cubed mark with distilled water. So they give us a diagram here. The diluted solution is titrated against the hydrochloric acid solution of the concentration as calculated above. During the titration, 22 cm cubed of the diluted ChemClean solution is neutralized by 18.7 cm cubed of the HCl solution. The balance equation for the reaction is, so 19.2.3, calculate the mass of ammonia in 1 dm cubed of ChemClean. Now this is a 7-mark question, and so it's going to involve multiple steps. Now, the way I do it, the way I would prefer, or I suggest we do this, is by breaking it up into small pieces. So I'm going to go into a new page here, and what I'm going to do is I'm going to just sketch out exactly what's happening. So we have a 1 dm cubed container, so 1 dm cubed here of my ChemClean. Then we take out 25, or is it not 25, it's 20. So we take out 20, so 20 cm cubed, right? So what I like to do is I like to make a note, what's going to stay the same, what's going to change. So this is taking out or pouring. So during pouring, the concentration stays the same. So concentration is the same, right? The volume will change, but the number of moles as well. So N changes. Okay? Then this 20 cm cubed of ChemClean is diluted. It is diluted. Now when it's diluted, it's filled up to 250 cm cubed mark. So it's filled up to 250 cm cubed. Now during a dilution, what stays the same? What changes? During a dilution, the concentration changes and the number of moles stay the same. Notice when you're pouring things out and when you are diluting, you use the same things. So concentration and number of moles, one will change, the other will stay the same. Then from here, again, they poured out. So poured. Now for the titration, how much did they use? 22 cm cubed. So 22 cm cubed was taken out from here. 22 cm cubed. And again, when you're doing a pouring, what stays the same? What changes? When you are pouring, the concentration is the same and number of moles changes. And it was at this point that they did a titration. So let's look at the information. And now they want to know what is the mass at the beginning. So we're going to have to work backwards to get the answer at the beginning. Okay. So we are at this point at the 22 cm cubed. That is the volume of the ChemClean. That is the volume of the base. So this is volume of the base. What other information do we have? Let's take a look. They tell us 18.7 cm cubed of HCl. So 18.7 cm cubed HCl, and the concentration of the HCl is as we worked it out before, which was 0.1. Now that we have most of the information, let's get started with some of the actual calculations. So what we don't have is the concentration of the base. So that should be our starting point. And since it's a titration, we can use the CAVA formula. Now I'm going to start it off by writing CBVB divided by CAVA is equal to NB over NA. Now the reason why I'm switching it is because I don't know CB, and so I want to just make the calculations a little bit easier. Now let's substitute CB multiplied by 22 divided by CA was 0.1 and then VA was 18.7, and now let's look at the ratio in our reaction. So we can see here that the ratio is 1 to 1. So here it's just going to be 1. Now we can calculate CB. We'll say 22 divided by 0.1 multiplied by 18.7. And we can put that in our calculator and we will get an answer of, so CB multiplied by 200 over 17 is equal to 1. That means CB is equal to 1 divided by 200 over 17, which is 0,085 moles per dm cubed. And this is the concentration in the 22 cm cubed sample. Now, let's work backward. Now, we have the concentration here. Let's look at this point. So if I want to go backward, let's look at what happened. It was poured out. So if it was poured out, the concentration stays the same. So if the concentration in the 22 is 0,085, then the concentration in the 250 is also going to be 0,085. Now that we have the concentration in the 250 cm cubed, we can go backward here to figure out the concentration in the 20 cm cubed. So what happened? There was a dilution. And now if we want to do a dilution, there is a dilution formula. So the formula is C1V1 is equal to C2V2. Now let's look at the information that we have. On this side, we know that the concentration is 0,085 and we know the volume is 250 cm cubed. Here we need to convert. So 0,25. And that's equal to, on this side, the volume is 0,02 multiplied by the concentration. Now we can work out the concentration. We'll say 0,085 times 0.25 and then divided by 0,02. And that gives us an answer. So concentration is equal to 1,0625 moles per dm cubed. And this is the concentration here. Now that we have the concentration here, we can then go back to our original sample. So what happened between there? There was a pouring. And if there was a pouring, the concentration stays the same. So it means that the concentration in here is also going to be 1,0625 moles per dm cubed. So we know the concentration, and now that we know the concentration, we can work out the mass. So we can use the formula concentration is equal to mass divided by molar mass times volume. Now we want mass, so take everything else across. So mass is equal to concentration times molar mass times volume. The concentration is 1,0625 multiplied by the molar mass. And what molar mass are we talking about? We are talking about the molar mass of the ChemClean. But the ChemClean is actually NH3. So NH3 is going to have a molar mass of 14 for nitrogen plus 3 hydrogens, and each hydrogen is 1, so 3. And then multiplied by the volume, which is 1. So 1,0625 times 17. And that's equal to 18,0625 grams. And that's our answer. Now let's take a look at the last question. 19.2.4. Will the pH of the solution at the end of the titration be greater than 7, equal to 7, or less than 7? And then use or write down the relevant equation to motivate the answer. So to answer this, it's testing to see if we understand how hydrolysis works. Now, there is obviously an easy way to solve this, and the easy way is just to remember the types of reactions that we get. And the reactions are basically, if you have a strong acid plus a strong base, that's going to give us a neutral salt plus water. If we have a strong acid plus a weak base, we are going to get an acidic salt plus water. If we have a weak acid and a strong base, we are going to get a basic salt plus water. Now, the salt is neutral, acidic, or basic, and the way that we can explain why it is neutral, acidic, or basic is through the process of hydrolysis. So why it's going to be one of these things is explained through hydrolysis. Now, before we even look at the process of hydrolysis, let's figure out what the pH is going to be. So NH3 is a weak base. So this is a weak base. And HCl is a strong acid. So a strong acid and a weak base will give us an acidic salt. So the pH here is going to be less than 7. Now we need to figure out why. So to figure this out, let's look at the process. So we want to look at hydrolysis of the salt, right? So hydrolysis. So step 1 is we need to analyze or evaluate our salt. So our salt is NH4Cl, right? So that's our salt, right? NH4 plus Cl minus. Okay, now let's evaluate. What are the ions? The ions are NH4 plus and Cl minus. So how do we evaluate it? First thing we need to do is we need to look at what compound did it come from. So NH4 came from NH3 and the Cl came from HCl. Now, as we said earlier, NH3 is a weak base. That would make NH4 plus a strong conjugate acid. HCl is a strong acid. That would make Cl minus a weak conjugate base. Now, when you want to do the process of hydrolysis, it's only going to be the strong ion that's going to undergo hydrolysis. So this is going to undergo hydrolysis, right? So you're going to have the NH4 plus the water, and that's going to give us, now let's look at it. If this is the acid and that's the base, then remember acids are proton donors. So an H is going to be donated here. So we're going to be left with NH3 and then plus H3O plus. The formation of H3O plus tells us that this solution is going to be acidic. Now, of course, the process will apply the same way for if it's basic, but instead you're going to form OH minus. And that's it. Thanks so much for watching. I'll see you in the next video.